Welcome everyone one more time into my class. Today we will learn about the transpose matrix and um, I'm making a video on all the different matrix topics. So if you like it, please give me a thumbs up or subscribe my channel. That will help me to grow. My main motive is to basically whatever knowledge I have, if I can share and if that help anyone, that will be very awesome. Thank you. So let's jump into the class. Okay. So transpose matrix right now, let's consider I have a matrix X, and by this you can see that it has m number of columns and sorry m number of rows and m number of columns. So we can say this is a m by n matrix. Okay. What does the transpose matrix mean? Transpose matrix is denoted by X capital T, and what it will happen basically internally these values will change by diagonal. What does it mean? It will be 1 1 and then this row will come as a column. So x 1 2 x 1 3 x 1 p, this will come as my first column like this. So then second row will come as my column. So x21, x22, x23 will come like this, and x2p will come like this. Okay, and the last one will be x m1 to x mp. Okay. So this is the way this transpose will happen. So what does it mean? That our diagonal elements, there will be no change on the diagonal elements. So my diagonal elements was this one. So absolutely there is no change into my diagonal elements. But if you see this, this is like a reflection. Okay. So your this value will move here. So like this, if you see, this is the changes happening. So that is called the transpose of matrix. Okay, hope you understand. By chance if it is not clear, so let me just give a small example. So let's consider we have a matrix of 1 2 3 and 4 5 6. So let's consider we have a matrix, and if we do the transpose of this one, what will happen, it will basically convert into a number of rows will be changed and number of columns will convert, right? So m by n, okay, sorry, my mistake, this is m by p. Okay, because I am considering p is my number of n by p. So here this matrix was basically p by m. Okay, so in this case this was initially basically 2 by 3 dimensional matrix. This was initially the 2 by 3. The transpose of this will be 3 by 2 dimensional matrix. So what does it mean? It will be 1 2 3 and then 4 5 6. Okay, hope it makes sense. So I think it is clear when you are doing the transpose, basically your number of rows and number of columns are getting changed. You are getting a new dimension matrix. If it is a square matrix, obviously there will be no change. But if it is m by n or m by p, then it will be p by m kind of matrix. Okay. And mathematically, like if you want to write a specific element, like let's consider I want to write x, the small element ij of the transpose element, which is nothing but x of ji, right? Because that's why I mentioned here, like After transpose, whatever element you are getting, this 1, 2 is nothing but your 2, 1 element. So these values are getting changed. Hopefully the transpose is clear. Now using transpose, we have some linear algebra actually. So couple of important properties. So let's consider properties, and this is kind of your home task also. If you take a very sample, let's consider you take some kind of a sample and then try to prove it. Try with very simple 2 by 2 dimensional matrix and then try to experiment this thing. One thing is, suppose I have a matrix of let me erase it actually. Give me 1 second. Okay, I am back. Okay, let's consider I have a matrix A and transpose of that matrix, and again if you do the transpose of that matrix, the property says that it will return back to the original matrix. So this is a very important property, and this is property number 1. What is the property number 2? The property number 2 is, if you transpose of a sum of two matrix will be always equal to A transpose plus B transpose. And you can just play with some sample matrix and you can check this, but these are the properties. Important property, I'll just use the different color so that you can remember it. So this is important, okay, because okay, so important property is multiplication. When you do the multiplication or product of two matrix, then it will not follow this property. It will be B transpose into A transpose. So the order is matter. Remember this. This is very important. The order is matter. Okay. Let me write it down. The order is matter. Okay. So it will be B transpose into A transpose. So this is a very important property. Okay. Now, using this properties, using these transpose properties, we can discuss about two more things. One is called symmetric matrix. So S symmetric matrix. Okay. What is symmetric matrix? Symmetric matrix is saying that A transpose equal to A. Okay. Now, what does it mean? When this property is satisfying, that is called symmetric matrix. And symmetric matrix, if it is satisfying the property, that's mean when first of all, if you think about when you are doing the transpose, what is exactly happening? It's basically, if you think about your diagonal line, there is no change. So let's write down the diagonal line, probably A, D, F. So there will be no change on this one. But what does it mean? If you do the transpose, still you are getting the same one. That's mean when you are transpose, what happened actually? Your this elements swap, right? So that's mean this one and this one are same, and this one and this one is also same, and this one and this one is also same. Okay. Yep. So let me just erase it and write it properly actually, so that it will be easy. Okay. So and say A, B, C, and B will be here again, D, E, Now C will come here, E will come here, and F will come here. So these two will be same. Whenever these elements are same, that's mean this, if you do the transpose, it will create a symmetric matrix. Okay. One last thing which I want to cover in today's video, then probably it will be complete about the properties, that is called the skew symmetry. Okay, it's called skew symmetry. Skew symmetric matrix. Okay, so here the property is saying that A transpose equal to minus A. This is the property. Okay, so what does it mean if our data or matrix looks like this? So look, if it is negative 0 is happening, that's mean all the diagonal elements definitely has to be 0. And whatever with the other elements, they will be negative. Then only when you do the transpose, you will get back the same one. Okay, so let's write down the C here, and this will be minus C minus E. Oops, let me just write it first so that I can explain properly. Okay, let's make it clear. So 0 B C minus B, 0 E minus C minus E, and 0. Okay, so few things why we are talking about this symmetric matrix. If you think about, like, if the symmetric matrix is there, then basically number of independent elements are getting reduced, because in this case we have, when it is 3 by 3 dimensional matrix, we have only 1 2 3 A B C D E F, only 6 independent elements. Here it will be very less, only 3. So that's the skew symmetric matrix. Okay, so that's why all these terminologies, all these things are very important. So once again, let's just quickly review. So transpose matrix, when you do a transpose, it's basically converting from m by n or m by p matrix to p by n matrix. So 2 by 3 is getting converted to 3 by 2 because number of rows and number of columns are getting changed. What are the important properties? So let me probably just put in a red color. So one property is A transpose, and then transpose is returning back the same matrix. Summation is basically giving A transpose plus B transpose. Very, very important property is when you are doing the product and then taking a transpose, then the order is very important. So this is the third matrix. And then we discussed about the symmetric matrix and skew symmetric matrix. Okay, please try to do some test at home with these properties. This will definitely satisfy, but if you do a little bit of hands-on, you will completely understand the concept of matrix. Okay, hope you like it. Please give me a thumbs up, subscribe my channel. Once again, I will see you in the next video. Thank you so much. Bye.